I'm here to tell you why you can't do two things at once. Mostly to the males in the room, sorry, but I'm kidding. I'm very bad at it myself, but just a warning. So I'm trying to be beginner friendly. So part of that is sort of glossing over some things or sort of leaving things out. And some might say the things that I'd say are incorrect. I'll try and fix them towards the end. So if things are still looking incorrect to the advanced people, shout out then, but feel free to interject. But yeah, so if something seems a little bit like you're not getting the full story, so don't worry too much about it. I'll hopefully address it by the end. So, what are we waiting for? Let's get into it. Not a rhetorical question. We're actually waiting for so many things, just in general. Programming is, a lot of it's just waiting. Like, so API calls and reading a file, any in-out. We know that quite well for any Node developers, but just, we have to remember that, yeah, so everything takes time. Just, no matter what it is, right? So, and let's just, JavaScript's just out of the equation, no Node, whatever. So consider this pseudocode. So for any beginners or people coming from different languages, synchronous is sort of the paradigm that you might be quite used to. So idea is that, yep, so we have our file and then we're reading that file. Okay, cool. And then I'm going to do something with that file. That's it. Like, we read a file from a directory, then we do something with this file. So it's sequential. So this is quite intuitive to most people, right? So this makes sense. But the problem with this, of course, is that we have to wait for something to occur because everything does take time. This doesn't happen instantaneously. So if I read, so I want to actually do some other stuff after I do something with this file, right? But it's actually unrelated. It's not part of this at all. Like, it's completely unrelated to my cat list. But my cat list actually has thousands and thousands and thousands of entries, right? So it seems silly to wait. So there's this trade-off that we already had. So it's quite easy to reason about, but we do have to wait. So how do we avoid waiting? So again, ignore that Node exists, right? So the obvious answer, we do two things at once. Then we don't have to wait, right? So, and this is generally, a common approach is to spawn new threads, right? So we're still sort of in sequence. So we spawn a new thread where we process our file. So they're unrelated to each other, but still fairly, if you just concentrate on the actual file, this execution block here, it's still quite simple to reason about. We still sort of have this understanding, right? So awesome. So yeah, doing two things at once. And this is parallel programming. So that's at its core just doing two things simultaneously. So, and it could be 3 things, 4 things, but don't you hear this sort of like JavaScript is single threaded, yeah? Like, so, and especially to beginners as well, like this is what does this mean? Like single threaded. So right, so that means that we can't do that. There's no concept of these threads in JavaScript. So we just have to, so what do we do, right? So the thing is that we don't actually need them. So we can't do 2 things at once, but that's okay, right? So this is like, I think it's like Node School, so 101. So instead we read a file and we pass in, and then we have a callback at the end. So the callback takes in error and file contents. and we operate within that callback, right? So this is how we deal, there's no threads, right? But, so the end result might be if we do some other stuff afterwards. So we have that logical sort of, things are happening, like, sort of, who knows when, but it's not, this doesn't happen at the same time. So it's not like, so these two happen at the same time, but with read file from the FS and Node, we'll still pretend this read then do stuff is a callback, then the result is the same, right? Yeah. But then we just have to, but so why does it feel the same? Like why make these threads, right? So how is this working, right? So we only have a single thread. How else does this happen? So yeah, there's a thing called an event loop. It's a really big concept, but it's really sort of it's the idea of event-driven programming. And so this is critical, one of the foundations of JavaScript, right? And everything happens within this loop. But in a loop, there's only one loop, right? Nothing else. There's not two loops that are happening, just the one, right? And this is basically it. So like, this is the event loop set in JavaScript. There's a queue. A queue is full of messages. We're waiting for a message, and then when we get a message, then we'll process the next message. And that's the foundation. We just process one at a time, not at the same time. So that's it. It's a queue. That's at the core, just a queue, right? And so we have these messages, but what is a message? It's just whatever that we're doing at the time. So we have all these events. JavaScript itself was largely event-driven because it's interacting with user interfaces, and we're manipulating state. And user interface is always going to be giving us these new events, right? So a lot of it is not dependent on us as the developer, it's dependent on another party. So, and then a message has an associated function. So, and this is a callback. So once we go back to that loop, we go through and we get to that message, and then once we're there, we call the appropriate callback. So, and this is concurrent. This isn't parallel. They sort of feel interchangeable, but there's that little bit of difference, and that's really like the heart of like JavaScript, I think. Because, so yes, we can't do these two things at once, but we don't need to. So we're keeping track of lots of things. We're not doing lots of things at once, but we're making note of it, right? So, but the problem is it's harder to understand, right? Like, if you were expecting to understand the event loop after that, like, I'm sorry, but yeah, it is harder to reason about compared to our synchronous code, right? So that's one of the trade-offs that we make by pursuing JavaScript or pursuing using the event loop. So especially once you get, I think this comes back as well, is when you have the callback that's, you know, actually the third argument is actually a reference to the actual function called a callback. So we're already getting quite disjointed. So, and then we have another read file. So it's hard to understand where we are at any single point in time. And that's unfortunate, but that's actually why we have things coming up, like we have promises and async await that are slowly coming into the language. So they've been teething problems, but we're slowly getting a nice concurrent language with one day we'll have the readability. But for now it's sort of in the air. And so why not use threads? I mean, why did JavaScript go that way? So, I mean, we can't, so, but threads are hard. They're really hard, actually. They look really simple on the surface, but you do come into issues with, so yeah. So what happens if I work on the same piece of data in two different threads? So does anyone have an answer? What could potentially happen if you work with two threads? Sorry?
Race conditions.
Race conditions? I heard that like a few different times. Is that like coordinated? Yeah. Anything else? Yeah, inconsistency. That's so we have the same piece of data in two different threads. Suddenly, it's not so simple, right? And I ask this question because I have no idea, because I have JavaScript. I don't need to know anything about sharing memory and like multi-threading and thread safety and all that, right? So beyond that, that's taken away from me. That's fine for most of the use cases, because the benefit of threads is, you know, a lot of it is that sort of getting things done, sort of like without having to wait. We have that with the event loop. So this is sort of a bit more JavaScript specific, and we come back. So Node, the runtime, it's also single-threaded, right? So we can actually create new processes. So I lied. So you can actually do two things at once. So this is example of the child process. So you're spawning a list, so that's a common like shell command, and you list the files. So that's your basic sort of child process. And so it's not a thread, but we can create new processes. So it's quite self-contained. So threads sort of they share memory generally. So they belong to a process. So a process has a single thread at least. But yeah, so did I say that right? Yeah. Cool. So threads share memory. Like processes do not. There's this thing called IPC, inter-process like communication. So it's like you're less likely to shoot yourself in the foot. But process is also a bit heavier. Harder, like there's a bit more work involved. Obviously, like if you're spawning a process, but yeah, so that's really cool benefit. Like, so you can still do this parallel, just in a different way without threads, right? But so you want to shoot your foot, right? So and
I think it's just C for the foot. It's C for the whole leg.
oh, yeah. Well, I sort of meant this sort of as a joke, but also, the V8 runtime, like, sort of is basically, like, Node is, written in C++. So you actually can shoot yourself in the foot using Node if you really, really, really want to. So libuv sort of powers sort of a lot of stuff that's happening in Node. So you can use sort of native add-ons. There's also like add-ons that have done this for you, where you can spawn threads, but then you come into this whole issue of these race conditions. Like you have to actually think about this thing. It's a bit annoying. But JavaScript from the start, it's never been about parallel. So I ask, is it really sort of the right the right move to use it. Like, so even in these big applications, like, it's not necessarily the right move to scale. I'd be interested to hear who is actually sort of using clusters, like, in production, just to get to the sense of scale that you need to, like, to really look into, like, these problems. The last thing is food for thought. So, whilst we do have these, so JavaScript, yes, historically has been sort of asynchronous first, but these actually came into the JavaScript language this year, the ECMA script 2017 official, so shared array buffer and the Atomics API. The shared array buffer actually allows you to share, send a buffer across, say, like, example, like a worker thread, so share that buffer between two threads. So, and this is now, like, the first time this is sort of like in the JavaScript language, so it's not in Node, it's not in a web API like web workers, it's actually in the spec, the official spec. So, and I haven't seen any sort of how it will really work with Node. Yeah, I'd be interested to see, and specifically the Atomics API is because as soon as you bring in, like, sharing memory, you sort of have to work out how you're going to, like, stop people from, you know, stuffing things up, and the Atomics API was developed sort of with that. So now we're getting into actual parallel programming concepts. So that's sort of, yes.
Shared array buffer, shared between what and what?
So the examples that I've seen is it's specifically with web workers, so in the client side. So you can send. So what you do is you post a message with, because if you share, like, send like an array buffer, it'll post it, but then you have that buffer like in two threads. So when you send to that web worker. So specifically, I've seen it used in that context. Even though, like, I'd love to see non-web worker examples. But yeah, so that's a big one, and that, yeah, so it shares that memory between, the web worker threads. But yeah, so like, I'd love to see it, something else. So it's early days yet, but it is in WebKit, Chrome, I think Firefox has shipped it as well, but it's pretty much there. I mean, I don't think it's an Edge, but oh well, like, so I don't know, so sort of shot myself in the foot in that the idea of this talk was sort of to show, like, just because you could really, if you wanted to do parallel programming in Node, you probably shouldn't, but maybe you should, I don't know, like, people think this might be a good idea, so we'll see. So yeah, so that's all.